In this follow along, we'll take a look at an interesting article by Nicolau published in 2000 on IBX as an oxidant. Now, what I like about this reaction and why I highlight it is because we started with an alcohol and we oxidize the alcohol. And then what I'm going to show you is how this ketone can then be further oxidized to form an alpha beta unsaturated carbonyl, and then you can do it again. So if you have the means, you can just in one pot oxidize from an alcohol all the way to the alpha beta unsaturated system. Now, how does this happen? Well, I won't belabor the point and go through it again, but the IBX works like Des-Martin, DMP, and can oxidize the alcohol to the ketone. Similar process. What's interesting is how IBX can then react to give us the alpha beta unsaturated oxidized system. So how does that happen? Well, if you remember that a ketone is in an equilibrium with the enol tautomer. It exists. It's not the most stable, but it exists in an equilibrium. And when it's in its when it's in its enol tautomer, the alcohol can interact with the iodine. Now with some acid-base manipulations, we are here. Okay. And then at this point, it's the allylic proton, which from the solution, some O- floating around in the medium, so some conjugate base. What that may be, it's maybe another IBX O- species getting protonated, right? Because we've got all these protonations and deprotonations. I took off the extra proton from here. After, right, you see that it's not there anymore, but then you see that it's no longer OH, right? There's some proton transfers going on in this medium. So something is grabbing this hydrogen, possibly one of the O- from the IBX, from another IBX molecule, kicking the electrons in, pushing the electrons to get us here. This is our first alpha beta unsaturated system. And then you can repeat this whole process to get the double bond on the other side.